Today we're going to be talking about chemical reactions. Before we get started, I just want to go backwards a little bit and review a couple of terms with you. So previously, we've differentiated between a physical change and a chemical change. Remember, a physical change is not going to change the original composition or properties of our starting reactants. For example, if we go from liquid water to solid water, that's just a phase change, but that does not mean we change the property of water. So that's a physical change. However, when we look at a chemical change, we are going to change the original makeup. We are going to change the composition and properties of our starting reactants. For example, let's take sodium. Sodium is going to be a shiny, lustrous metal. If we react it with a poisonous yellow gas known as chlorine, we get the production of NaCl, which is sodium chloride, or better known as table salt. So table salt is white, it's grainy, and it has completely different properties from our starting reactants. Therefore, we know a chemical change has occurred. Here are some indicators we can look for to see if a chemical change has taken place. So you could look for the production of a gas in the form of bubbles, the production of a solid, this is also known as precipitation, the production of heat, the production of light, or a color change. Any of these things will tell us that a chemical change has occurred. So there's millions of different types of reactions. However, most reactions can be classified as belonging to one of these 5 simple categories. First being combination or synthesis. Those terms are going to be used interchangeably, so you'll hear both of those. Decomposition, single replacement, double replacement, and a combustion reaction. So we're going to take a deeper look into each of these chemical reactions. One of the main types of chemical reactions is combination, or also known as a synthesis reaction. As the name implies, simple reactants make or synthesize a more complex product. So you can see 2 or more elements coming together to form a product, or 2 or more simple compounds combining together to form a single more complex product. The basic format of our combination reactions are going to be A plus B combined to form a single product, AB. So I've included an example below. We can see hydrogen gas coming together with oxygen gas to form a single product, H2O, or also known as water. Here is another combination reaction. So if we take magnesium and we expose it to oxygen, it's going to have a chemical change and react to form a single product, magnesium oxide. So here we have magnesium, and it's going to be ignited in the presence of air or oxygen. A chemical change has occurred. This is obvious by the production of light. Therefore, the production of magnesium oxide requires a combination reaction. Magnesium oxide is going to have completely different properties from our starting reactants, magnesium or oxygen. The next type of reaction I want to talk about is called the decomposition reaction. So this occurs when one reactant is going to be split into 2 or more simpler substances. You could think of this almost as the mirror or the opposite of those combination reactions we just covered. Here's the basic format for it. We have a single reactant, AB, and it's going to split into 2 or more products, A plus B. So carbonic acid, which is H2CO3, is going to be an ingredient you can find in your soft drinks. So every time you open up a soda can, a decomposition reaction is actually going to take place. Your carbonic acid is going to be split into 2 or more products. Here we get H2O, which is water, and CO2, which is carbon dioxide. That production of the carbon dioxide from this decomposition reaction allows you to get that fizzy bubbliness in your soda. Our third type of reaction is called a single replacement reaction. These are going to be a little bit more complicated than our other reactions just because we have some rules, we have some restrictions that we have to be mindful of. Just like the name implies, we are going to see a single element that will replace a similar element in a compound. So I have the general equation listed below. Note, this is not going to be the perfect equation just because we do have some exceptions, we do have some restrictions. But in this general equation, we can see that element A is going to be our added element. This is the one that's going to be doing the replacing. In this scenario, A is going to replace B. That means that we are going to produce a new product called AC. Since A replaced B, our B is going to be released and it's going to be its own separate product. There are some restrictions on how single replacement reactions can occur. Only similar elements can replace similar elements. So cations can only replace cations, anions can only replace anions. So if you look at the general equation, element A is going to be the one that is doing the replacing. It's going to be the added element. In our example below, we can see that magnesium is going to act as our element A. It's going to be the one doing the replacing. So we have to look at the properties of magnesium. If you look at your periodic table, magnesium is going to be a metal. Just a reminder, metals tend to form cations. This lets us know that we are going to have to replace the cation in this compound. In the compound CuCl2, we know it's going to be an ionic compound. It's made up of one metal and one nonmetal. Think back to when we talked about nomenclature and we were writing the formulas for ionic compounds. Remember, cations are always written first and then they are followed by the anion. So based off of this information, we know that magnesium is going to have to replace copper. Therefore, we get our new product, magnesium chloride, and copper is going to be released. Keeping this in mind, that means that if the element that is doing the replacing, our element A, is a nonmetal, then it has to replace another nonmetal in the compound. Thus, our general equation is going to look a little bit different. So keeping this in mind, let's look at this equation. In this equation, our element A is going to be chlorine. Chlorine is going to be doing the replacing. Chlorine is also located in group 17, which makes it a nonmetal. And nonmetals tend to form anions. Given that information, we know that chlorine is going to have to replace the anion in our compound. Our compound is going to be NaBr. This is sodium bromide. This is also an ionic compound, and we know this because sodium is a metal, bromine is a nonmetal. When we talked about naming ionic compounds, cations were written first and anions were preceding. So our chlorine is going to be replacing our bromine and not our sodium. Therefore, our product is going to be NaCl. That bromine that was previously here is going to be kicked out and it's going to be its own single product. The only thing that you do have to keep in mind is that you have to make sure your diatomic elements are accounted for. So those are going to be our Hofnabrückel elements. So bromine is always going to exist in a pair. Chlorine is also going to always exist in a pair. Let's do an example. Identify which of the following equations correctly shows the reaction between aluminum and iron 3 oxide. So go ahead and pause this video and try to do this question on your own. You should have selected C. Aluminum is a metal and will thus form a cation. Cations replace cations in these single replacement reactions. Therefore, aluminum will replace the iron 3 ion in the compound and aluminum oxide is formed. Iron is then released. In single replacement reactions, we have to keep in mind that they will only occur when the element that is doing the replacing, so our element A, is more reactive than the element that is being replaced. Otherwise, this reaction will not proceed, it will not occur. So we have to use the activity series. The activity series is going to be a list of elements and it's written in decreasing order of their reactivity. That means our most reactive elements are on top and our least reactive elements are going to be down below. Since metals replace metals and nonmetals replace nonmetals, they each have a separate activity series. You are not required to memorize this by any means, but you should know how to apply it. Let's look at these two examples. In our first single replacement reaction, we have nickel that is going to be acting as our element that will be replacing. It's our element A. Nickel is a metal, therefore it's going to form a cation. That means it's going to replace the cation in this compound. This is lead 2 nitrate. Our cation is going to be lead. Therefore, nickel should be replacing lead. Let's see their reactivity on the right-hand side. Nickel is Ni and lead is Pb. Nickel is more reactive than lead. Therefore, this reaction will proceed. Our nickel is going to replace our lead and therefore we'll get the formation of nickel nitrate and the production of lead on its own. Let's look at the next equation. So our element A is still going to be nickel. That means it's still going to be a metal. It still has the tendency to form a cation. That means it's going to replace the cation in our compound. This compound is iron 3 nitrate, and our cation is going to be iron. Therefore, we need to look at the reactivity of both nickel and iron. So I'm going to use my activity series over here. Nickel is Ni, iron is Fe. If you notice, nickel has a lower reactivity than Fe. Therefore, this reaction cannot proceed. It's not possible and it'd be very unfavorable. Therefore, you're just going to write no reaction or Nr. Go ahead and try these on your own. Determine whether this reaction will occur. If cadmium is exposed to zinc nitrate, use your activity series to see if this reaction will proceed. Pause this video before going ahead. This will produce no reaction. Cadmium is the element that is doing the replacing. It is less reactive than zinc, therefore no reaction will occur. Go ahead and try this one. Will this reaction occur? If we put zinc with cadmium nitrate, use your activity series to determine whether this reaction will proceed. Pause this video before going ahead. This reaction will produce zinc nitrate and cadmium. Zinc is the element that is doing the replacing. It is more reactive than cadmium, as seen in our activity series. Therefore, zinc will replace cadmium to form zinc nitrate, and the cadmium that was previously here is now released.